Hi friends, I am Bimal. Today I am going to show you how to design the bridge in Metacivil as per IRC code IRC 112. This is the following steps you have to follow to design the bridge in Metacivil. At first, unit setting, define the material properties, define the section properties, create the geometric model, define the groups, define the boundary condition, define the static loads, define live load combination, perform analysis, result analysis, RCC design, at last the design code. And this is overall view of the slab. The length of the bridge is 10 meter and overall deck is 8.4 meter. And here the cross section in longitudinal direction, and the length of the bridge is 10 meter and I divided into 12 sections. The intermediate 8 sections are each of 1 meters and outer 4 sections are 0.4 meter and 0.6 meter. And here the cross section in transverse directions, and the width of the wave is 7 meter and I divided into 7 sections, each of 1 meter, and width of the flange is 0.7 meter and the depth of flange 0.225 meter, and the overall depth of the deck is 0.7 meter. At first you open a new project and set the units. Here kilonewton and meter already has been put, but I am going to show you how to put the units. Here go to tools and click on unit sets, meter, kilonewton, and in temperature will be more suitable for you or maybe for me. And the next step is define the property sections. Here the material property, at first you have to define the material property and add the material will be concrete, and I am going to define the name M30 IRC code. Put here the IRC code IRC M30, and the uh, remaining data will be automatically input here and apply. And next I am going to define the material as dummy for the dummy members, and in case of dummy you have to select the none. Automatically it will be filled here, but weight density you have to put here 0. So in case of dummy members the weight density will be 0, you have to put and apply. Okay, close all these things, and the next you have to define the section property. Add the sections will be rectangular, solid rectangular, and define the name. I am going to define the mid section and click on user. User means I am providing the height and breadth. Height will be 0.7 meter in case of mid sections, and width will be 1 meter. I am taking this one and change the offset center to top, center to top. Okay, and apply. Now define the another sections. The section will be also solid rectangular, and define the section name end section. End section. Click on user. The height will be 0.225 and the width will be 5 meters, and change the offset center to top. Okay, apply, and define the dummy members. Dummy. In case of dummy, click on user, and it will also be solid rectangular, and the height will be 0.225 meter, and width will be 1 meter also, and change the offset center to top. Okay, and apply. Define for the crash barrier, dummy crash barrier, and the height and width will be, I am taking similar. Offset you have to change and apply. Now close all windows, and next create node and elements. At first you have to create a origin. Here 000 will be the origin, and then next apply, and you can see here this is the origin. Now I am going to create a beam elements with the help of extrude options. Click on extrude and take M30 mid sections, and you can also take this point equal distance, and you can also click on these points here unequal distance. So I am providing the unequal distance, that's why I am going to click here, and I am going to put the members, beam members will be along x direction, so put here. At first I am providing 0.4 meter, length of the beam will be 0.4 meter. So okay, apply, and it will be along the x-axis, so apply, sorry, and you have to select the points and apply. This is the beam element 4 meters, and select the points, and now I am creating 0.6 meter, 0.6 meter. Next, select the points, and now I'm going to make 8 meters length of a beam at 1 apply. Here 0.4 meter, 0.6 meter, 1 meter, 1 meter, 1 meter, up to 8 times. And the next also 0.6 meter, I am going to put the length of the beam 0.6 meter and 0.4 meter. So click this point, select this point and put here 0.6 meter, apply. Next, select this point and put here 0.4 meter. This is the beam element along longitudinal direction. This is the beam element along longitudinal direction. You can see this is 0.4 meter, this is 0.6 meter, and 1 meter up to 8 times, and the next 0.6 meter and 0.4 meter. This is today view. And now I am going to translate this beam element along y-axis. Select the beam element and translate it. Click on translate. I am going to translate in y-axis in equal distance, or maybe you can use the unequal distance. So in equal distance, I am taking along y-axis 1 meter 6 times. In 6 times it will be, and also click here and apply the 3D view. This is the 3D view. Translate it along y directions. The distance will be 0.85. Apply, and also the outer beam translate in opposite of the y directions. So in case of opposite of outer directions, you have to put here the negative sign and apply. You can see the 3D view. But in that case, the end beam property, so top view, 2D view, and select the both outer select the both outer beams, and go to close, make it, and go to the end section and click and drag here. Okay. The 7 beams are mid sections, and both outer 2 beams are end sections. You can check here. Now I am going to provide the dummy members. At first, you have to translate the nodes. At first, you have to translate the nodes, both outer sides. Here, translate the nodes along y-axis 0.35 up to end of the structure. Here, copy intersect frame element, click here and apply. This is already, has been translated, and the same process you have to apply here. Select the nodes and elements, but I am going to translate the only nodes in opposite direction of the y, so you have to provide the negative signs and apply. So you have to click the outer all nodes and use the extrude options. Here the material property shall be changed, and the dummy members, I will provide the dummy members here, and equal distance unequally. Here the element will be created along the y-axis, but in case of y-axis all nodes are not in equal distance, so you have to use the unequal distance. from from this node to this node is 0.3 meter, this node to this node is 0.85 meter, and up to the 6 times it will be 1 meters, and up to the 6 times it will be 1 meter, and next will be 0.85 meter, and outer will be 0.35 meter. So I am going to provide here in case of unequal distance along y-axis. At first I am going to put 0.35 meter comma space 0.85 meter comma space, and 6 times at 1 meter comma space, and 0.85 meters comma space, and 0.35 meters, and click on apply, and click on apply. Here the dummy members has been created. You can see all the dummy members has been created. Now you can see the 3D view. Click here and you can see. Now I am going to create the dummy crash barrier elements, both outer side at both outer sides. So go to create the elements, click on material dummy, and the section will be dummy crash barriers. Click here, node connectivity. Okay, click on one node to another node, one node to another node. The process, you have to repeat the process on other side also. And now you can see the 3D view. Click on 3D view. You can see here. Now you can see the 3D view. This is crash barriers. And now I am going to define the groups. So go to work and double click on dummy members, and all dummy members has been selected. Open the key menu 2 and create the structural group. Give the name cos, add, and make it close. Now click here and drag here. You can see 130 elements have been grouped here. Now I am going to define the boundary conditions. Here I am providing the bearings, and also at the mid and also at the side at bottom of the day. And I am assuming thickness of the bearing will be 0.1 meter. So the nodes have to translate at the bottom of the deck and 0.1 meter. So select the and come to the 2D. Yeah. Select the nodes and middle nodes and side nodes, and translate it minus 0.7 meter, and apply. You can see the nodes have been translated at the bottom of the deck, and now I am translating it up to 0.1 meter. and the similar process you have to repeat here. 1 meter. Apply. We have to provide elastic and rigid link. Go to boundary condition, go to rigid link. In case of rigid link, the rotation and displacement all along all directions will be fixed. And click here the master node. This is master node, and select this point, and next this is the rigid link. And then now I am going to provide the elastic link. Click on elastic link. Here it will be and now click two nodes here, and you have to repeat the process for the other cases. You can also click here, and along the y direction you can also provide the distance, and automatically the remaining points will take the elastic link. Okay, make it display. And make it display. Up to the defined boundary condition has been completed, and the remaining 6 steps I will show you in the next videos.